So
Yep.
I'm Jay Wilkerson. I'm here today to talk about Jank, which is a programming language I've been working on for a while. It's a Clojure dialect, where Clojure is a one would say practical Lisp on the JVM, but it also runs on JavaScript. It runs on CLR, runs on Beam. So it kind of just latches on to various dynamic hosts, and then it can run there. But the default implementation is on the JVM. Jank is a dialect of Clojure, and I'm trying to bring all of what I like about it to the native world. And one of the big things around that is interactive programming and REPLs, and this is where Cling comes in. So details here. Won't say anything more about me until a little bit later. So let's take a look at what I like to cover here in terms of broad strokes. So I would like to show an interactive programming demo of Clojure, and this is because when we talk about interactive programming, when we talk about interactive C++, when we talk about REPLs in general, I think there's a disconnect between what like mainstream programmers think when they think REPL, potentially what Cling programmers think when they think REPL, and then what Clojure and Lisp programmers in general think when they think REPL. So I'd just like to show sort of what things are like on that end. And then also, I'm going to dive a bit into Clojure's and thus Jank's interactive compilation model, which, coming from my background of like lots of systems programming in C++, kind of blew my mind over and over again as I was coming up with like how to actually do this in Jank as well. And then the last thing would be to talk about the road to interactive programming. You know, what I was able to demo today in Jank, talk about, or in Clojure, how I can get there in Jank, and what's needed for that, and where I am, and you know what's remaining. So I'm going to be covering a lot of Clojure here, and primarily that's because Jank is a Clojure dialect, and also Jank is less developed than Clojure. So I can't demo things like the interactive programming that I want to show today. But I'm trying to show what how I'm trying to get there. And then, we can see how this would apply to a native world, where we can work with, things like Qt programs, or Vulkan games or so on. And I do have a couple of live demos, so hopefully we don't have any big surprises there. I will say, please hold your questions until the end. My understanding is that there's going to be some time allocated there. So with that said, let's jump into interactive programming with Clojure. Now, I want to talk about REPLs here, and like, what does a REPL mean to me? What does a REPL mean to you? And I've given this talk to a different group, and it was slightly different because they were more mainstream programmers, whereas you guys are kind of in a different niche altogether with Cling and the compiler research, and on top of that, data science. So on a surface level, like, I don't need to talk about what a REPL actually is to you guys, but there are different ways that it manifests, right? So mainstream programmers, when they think REPL, they think, okay, I'm going to type node, and then I can, I have a read line loop, and I can start typing some things into that and getting some results. And you could do this in Clojure as well, as I demonstrate here. It's all effectively the same. Now, there's another group that when they think REPL, maybe they think more interactive programming with like Jupyter Notebook, for example. And that is like the world of interactive programming, like, that I have seen in existing Cling videos and demonstrations, like from Vasil, like is entirely outside of what I work with. My background is in game engines, game development, game servers, game tooling. So very different world in terms of like, when I'm trying to get interactive programming, it's because I want to start with an empty process and then build it up into a game server, or I want to build it up into an actual game on the fly without needing to stop, recompile my game, run it again, do some more testing. I want to be able to just do that interactively. Now, I have seen some uses of this in Clang with regard to, like, I think there was some music creation that was doing something along these lines, but it didn't quite achieve, I think, what the Lisp world and the Clojure world has been doing for a while, and I'm hoping that it gets there. So let's jump into a little bit more what I mean here. This page is intentionally left blank because this is the first demo time. So I'm going to jump over to a terminal now, which, based on my Zoom testing, you will all be able to see. So if I spin up a REPL here, this is just a Clojure REPL, and we can verify our sanity here. Yep, okay, great. But there's something else one can notice here, and that is this nREPL server started. This is a hint toward something greater, and nREPL is a standard network protocol that has been developed primarily for Clojure to allow editors to talk to REPLs, but it's not just for Clojure. And in fact, Jank will be using it as well. So we can see this when I jump into a Clojure file here. In the top right of my Vim window, we have this localhost connected nREPL port, right? So automatically my editor connects to this REPL session. Now the REPL, when I start it up, it has nothing. It doesn't have any of my namespaces, any of my modules, any of my functions. It doesn't have anything. But I can just send it whatever I want on the fly. So in this particular bit of code, I have here a web server. And let me actually, let me just show there's nothing running right now. However, I'm going to send that. So I just sent this whole buffer to the REPL, and each of these top level expressions was evaluated. And we can see that here in the results in the top right hand window, the result from each of those evaluations. Now let me jump into the bottom here, and I have this start and stop function. I can just evaluate this start function by sending that to the REPL to say, hey, I want to evaluate the start function in this, the context that I am. Now our web server has started. So now I can curl localhost 3000, and I get back some JSON. So that's already a good start in terms of the interactive programming. I didn't need to do anything specific to start up my my service. I just started up my REPL, and then I turned it into whatever I want. If I want to turn my REPL now into something else entirely, a GUI application, I could do that as well. I just got to send that code over. So bear with me as I type this. But the whole point here is to demonstrate interactive programming. So I want to actually make some HTTP requests, and that's because so much of what I do these days is HTTP requests, and it seems to demonstrate what a real world programming for me. Plus, coming up with examples for what to do in an interactive session is tough. So I have this Hacker News API and a post about Jank, a recent post about Jank. Now I just want to be able to hit that API and say, hey, give me that post. So I type up this HTTP request, give it the URL, say I want JSON, and then I run it. Now in this top right-hand window, we get to see the results, but that's not very easy to read at this point, so I'll just make a split. Now what we get back is, so Clojure is I wish I could tell you so much more about Clojure today, and teach you guys more of the language, but we don't have time for that. But one thing I will need to say is that Clojure is not only is it just a Lisp built on primarily JVM with the goal of being super practical, it is unlike something like Scheme or Common Lisp. It's very much built around a standard library of immutable persistent data structures. and values are transparent. So this is a map effectively that I get back of key and value from my HTTP request. And so I have my headers inside of here. I have my body inside of here, which is a string. This is all good, but let's actually do something a little more. So I want to get the body out of that, and then I want to do I want to turn that JSON string into a Clojure map in this case. Great. So now I have done exactly that, and I get this data back here. Now I'm having this data printed here, but I actually have full access to it as well. So I could def it here and then have access to it if I wanted to just work on massaging it. I don't need to keep doing this HTTP request over and over again. But also I haven't put this in a function yet. This isn't even code that would compile because it's in a comment block right now. Comment block's actually just a macro that expands to nil. But let's pull this out. So we'll say, all right, we have this fetch post, takes an ID. We'll need to use ID here. That would be good. And yeah, so now we can just update this, say fetch post ID, effectively the same thing. But now when I evaluate this, we have a function. So I could say, okay, well, what is fetch post, for example? And it says, okay, well, it's this function object. So now that function exists in my process. Now I can redefine this function willy-nilly as I want as well. And any reference to it is going to maintain that reference to it. One of the interesting things about the way that Clojure works with this. But let's dive into a bit more about getting the data here. So when we take a look at the result of this particular post, it has a title, it has some descendants, which are called kids, and they're referred to by IDs. So I actually want to go fetch all of the children of this post as well. So let's make a separate function here, and we'll just say fetch children, and it's going to take all of those IDs that were called kids. So here I'll just do I'm just going to map a function. So I have IDs, map a function that takes in a single ID, and I could do the same get here, but this is just a recursive sort of relationship. So I'm just going to do a fetch post, and then we have a mutually recursive relationship here. So let me just forward declare fetch post. Great. So if I do this now, I'll just need to wrap this guy in a let, and that's our post there. And then I can say inside of here, well, I also want my children. And I can say fetch children. And then inside of this post, we can see, yes, we have kids. So I can just say, all right, give me the kids post. And if we just want to put these together, I could do something like put the post on the children. Great. Now if we run this, I'm actually just gonna, I don't want to get all of them because it's a lot of data, at first. So I'll just say, yeah, I'll take the first of the kids and then run that. Great. Now we're getting back, some more complete data that we can actually work with. So I could, I'm just running this now and then I lose that data. I could say, yeah, let's take a look at this by just running the same thing, but now I want to put it into comments, right? And so comments, this has been defined into a top level var, even though that was written inside of a comment block. I've evaluated it, and so it's there in the process space. So I could say, like, all right, well, how many comments do I have? I have 2 in this case, because I have a limit here on the take 1. But I could do any sort of work I want on comments. Let's say, for example, I wanted to, so I'll remove the limit that I have here, send all of that to the REPL again, which includes redefining the fetch post function, and now reevaluates def comments. Now, one thing I'll note here is that every time I send something to the REPL, it's just-in-time compiled. So in the case of Clojure, it's being, Clojure JVM, it's being just-in-time compiled to Java bytecode, right? Now, in the case of Jank, it's being just-in-time compiled using cling and then added to the process, but effectively the same result. Now, let's just do a little bit of work on comments. This is arriving us to our final goal here. So we have, let's just do a filter on the comments, and we'll say we want to find, does this, so we want the text of the comment, and does this include a particular word? So I don't know, great. Let's run that. No, none of them include great. What about amazing? Amazing, great. That's we'll have to accept that I will make errors there. No. Is that because what about unfortunate? Can I verify my sanity here? Nope. We actually have an issue here. Let me see. Okay, there we go. Nice thing about interactive programming is it's very easy to just change your code and reevaluate it and get your result back. And this is day-to-day programming in Clojure. Cool. So what I want to do here is I just want to pull this up into a final function. We'll just call it find word, and it's going to take in the comments, and it's going to take in a word, and then it's just going to search for that word inside of the comments. Now, we have this function. Let's actually call it. So we have this default root, which I hit before. It gives me back meow1. That's just a I'm defining a root to say, okay, any GET request to here, respond with this expression. Right? I can do the same sort of thing, except I can destructure the path here to say, okay, anything / word, give me that word. And now let's actually find that word. Now, the really neat thing here is that I have not actually defined comments in the program as it would run if I killed my process and I ran it right now. But it's in the memory of the process because I've sent it to the REPL from here. So when building programs in a REPL like this, we do need to be mindful of well, is this going to work actually when I kill the REPL and I start it up again, and I send everything over because maybe I had everything in comment blocks. That's why we tend to start in comment blocks like this, tinker, and then promote things to functions, and then start hooking things together in a more complete way. Right. Let me just send that whole buffer to the REPL again, and verify sanity check that our root still works. And now we can do dream. That's no good. Let's format that. Great. So this is people responding with that particular one, and then of course unfortunate, this guy doesn't like the name of Jank. But I have to keep showing that one to remind myself. Not everyone is ecstatic. Great. So this is what I wanted to demo here with regard to the interactive programming. This is, as I'll say again, this is day-to-day programming in Clojure. So I have been working with Clojure for about 7 years now, including backend development, distributed servers, front-end development using Clojure script, which compiles to JavaScript, to build front-end applications. Then I've used it, Clojure CLR, inside of Unity 3D to make games. For every single one of them, I'm in my editor, I'm just sending code, and then actively building up a process on the fly. Great. Moving on. So Clojure's interactive compilation model. Let's take a look at this because first off, I'm not a compiler expert. I'm a hobbyist, when it comes to compilers. But I still have a pretty good idea of how like a C++ compiler works at a high level, right? And that's the mindset that I use to approach it. And I also have like an idea of how like an interpreter works, for example. And Clojure's kind of both, right? It's neither, but it's both. So let's just take a look at an example here. Let me do a time check. Or 10 minutes. And so let's take some Clojure code here. This is mostly taken from the code that I was just showing there. We declare a namespace, HNQuery. We're going to require a dependency, in this case, JSON needs to core, and we're going to provide an alias for that namespace called J. And then we're going to define a few vars top level, right? So everything defined top level in Clojure is a var, and vars are super important, which is why I'm calling it out, because vars they're little containers for immutable values, and basically everything in Clojure is an immutable value or a container for an immutable value. And in the case of vars, they use software transactional memory in order to update vars so that it only ever has the one correct value, but they can be redefined at any time. And this is really great for interactive programming because it means, yeah, that function, I can just change it. I can give it an entirely different signature if I want to. It's also really great for things like testing because I can say like, okay, well, for my test, I literally just want to redefine this function to always return an error. No need to actually go mock that in like a traditional sort of way, just replace the function. And you can easily do that within like a particular scope as well. But anyway, we have a top level effect here for this def config because we're going to slurp some JSON and then we're going to parse that. And then the subsequent defs are going to be based on that. This is important to call out. And then finally, we're just going to define, find word function. We did the same thing before, so I won't go into that too much. Let's take a look sort of group by group, what this actually looks like in the compiler, in the Clojure compiler. So we're going to compile this code. First thing we're going to do is we're going to expand the namespace macro because it's actually just a macro that expands to, let's just say, two things. First one says, okay, well, I want to create the HNQuery namespace if it doesn't exist. And also I want to require the JSON needs to core, and I want to add an alias for it. So the Clojure will have this, the Clojure compiler will have this internal representation of, okay, we have these namespaces, two namespaces. First one, HNQuery, don't have anything inside of it that I know about, but we have JSON needs to core that has a var that I know about called revalue. And we got that from going to actually require that namespace, which of course is a recursive sort of process. And then we have this namespace alias here that we just add to say, okay, J is JSON needs to core. These are just Clojure symbols, starting with a single quote. Now, for the top level effects, we're going to define these. And again, every single thing here that we're evaluating / compiling, we're going to just-in-time compile, and then we're going to evaluate. So these are all top level things. We're going to actually just-in-time compile, def config, and then the expression here, and then we're going to evaluate those, and those are going to update the namespace map to say, yeah, we have these 3 vars inside of the HNQuery thing. But that's also going to just-in-time compile this particular expression that's going to slurp and read that JSON value, right? And then it's going to evaluate that. And then we're going to define this function as well, which adds another var inside of the HNQuery namespace, right? Cool. So we just evaluated all that. Or wait, I thought we were compiling. Yeah, we are compiling. So what's the difference there? Because we just ran all that code aside from actually calling the find word function. So when compiling, we only evaluate top level forms. But that can mean any arbitrary effects, which is really useful for doing things like loading your config into your build so that it will be there when you build. But it's important to note that there's no entry point that's called. We're not going to run your whole program unless you're actually calling your entry point at a top level, in a top level expression, which you could be. That would work. But the only other thing is that all of the bytecode that we're generating when we just-in-time compile, there's a flag in the compiler that says, am I compiling or am I just evaluating this? And if we're compiling it, then we'll take all that bytecode that we generated at a file level and we'll write that to disk. Because after we compile / evaluate all of these files, we're then going to take all of those, in this case, for Clojure's JVM, all of those class files and bundle them up into a jar. And there's our distributable program. But otherwise, compiling is indistinguishable from evaluating. Now, in terms of Jank, I've been working on this for several years. It's gone through a lot of iterations. It started out not being a Clojure dialect at all, but it has always been a Lisp of sorts. It is now, though, I've been working with Clojure for 7 years as well. And at this point, I've realized, like, oh, wow, this is really nice. I like so much about, what this does. But also, I come from systems programming, and, I want to be able to, like, build game engines again, or, or do operating system development with something that at least compiles to native code. And so, thus, Jank has become a Clojure dialect, with an LLVM host. On top of that, Jank has other goals that distinguish it from Clojure as a dialect, primarily being a gradual structural type system, which we will not cover today, perhaps some other day. But today, wrapping all of this around, we have, well, how do I make Jank as interactive as possible? Right now, Cling solves a lot of this for me. And if Cling didn't exist, I probably wouldn't be doing this in C++ because I'd effectively need to build the equivalent of Cling. And the reason why I'm not doing this in Rust is because the equivalent of Cling does not exist in Rust. But now that Cling does exist, and and I can use it, we need to have good code gen from Jank to C++. Or potentially LLVM IR, but for now, for C++, we need to just-in-time compile that with Cling, and then finally we need to have good REPL support. In this case, I mean like nREPL, which is that technology that I was using before with Clojure, so that I could just do that same thing that I just did with that backend service, but with Jank. So code gen for Jank at this point is, this latest iteration of Jank, which is a Clojure dialect focused on interactive programming, is quite early on, because it's like the 4th iteration of Jank, I think. But we're at a point where I can actually use Cling to make some, useful things with this. And I have enough semantic analysis and everything to do the useful bits. So something like def A 222 and then print line A would end up generating something very close to this. So we have a struct generated name, it's a callable, has a constructor, has an override for a call function. First thing we do is we lift up the constants. In this case, I'm boxing it, could be optimized, not worrying about that at this point. We lift up the vars, so I'm defining A. Maybe A already exists, and I'm just redefining it at this point, totally possible. Print line is also a var that I'm referencing. I know this by just checking the local scope, and if it's not a local, then it must be a var. Otherwise, we have an error. And in the case of vars, we just intern them. So we say, which is saying, if it exists, great, give it to me. If it doesn't, create it and then give it back to me. And then finally, add the remaining code, which is in this case, var1. These are the actual generated names that were used. So I'm sorry, they're opaque. But var1, we're setting the root of that, which is the value inside of of that container of immutable values to const2. And then we're actually saying, okay, well, var4, which is the print line, we're just going to go call that. So we'll get the root of it as a callable, we'll call it, and then we'll give it the root of var1, which is that 222. That's all working. And the last thing to show, which is super quick, is just, let me, should have had this open. There we go. So yeah, we have this particular file here, which is, I think we just had A here before. And using Cling, finally, I can evaluate this, which is which which doesn't look like much, but it's it's taken a while for me to get here. I can do simple additional expressions as well. So A plus A gives me 444. Great. Next step is to push forward this Cling integration into Jank, and Cling has made this interactive programming experience that I want to achieve in Jank possible. I want to push that to where I can get this proper nREPL support, and then I can have that real interactive programming experience when I sort out the C++ interop from Jank. Clojure always has seamless interop with its host, so seamless interop with Java libraries on the JVM, seamless interop with JavaScript, in that world, seamless interop with in the CLR world as well. It's got to be the same thing for Jank. So you got to be able to call into C++ libraries. You got to be able to include header files and link to shared dynamic libraries, and just start working on them in like an interactive way on the fly. And once I have that sorted out with the REPL, now you can actually say, okay, well, great. Now I'm going to open up this GTK plus program, and I'm going to start developing it on the fly as well. That was everything I wanted to demo there. Before we get into any Q&A, if we do have time for that, just wanted to say, Vasil and everyone else, I appreciate you having me here, and I appreciate your time.
Thank you, Jay. With a pleasure. We have time for questions and comments, but first I just wanted to say it's very exciting talk, and it just opens a totally different direction or a totally different domain for me. I wasn't aware of any of most of these things that are even possible. So any questions or comments from the audience? If not, I can probably start with a few of mine. So when you said development, interactive development, building like incrementally a process, and then doing things on the server side, is how much of this is performance sensitive? So how much do you care about performance?
Yeah. When it comes to what most C++ people are thinking about, and sort of what was on my mind, honestly, even in like game engines, you have varying levels of performance requirements. If you're on a mobile game engine, or are you doing a game engine for a real-time fast-paced first-person shooter on PC or something like that. With Jank, I am not trying to compete with like real-time C++. Jank is not expected to have the performance characteristics of optimized C, C++, or Rust. Jank is meant to be competitive with Clojure, which is tough given the optimizing JIT that the JVM has, that has been developed for decades. But that should mean, especially since Jank does not have a garbage collector, it should mean that Jank should be viable for wherever you would use Go or C# or Java, you should be able to use Jank. Except in the case of like C# and Java, you wouldn't have a garbage collector that you need to worry about. So in the case of what I want to, when I'm working on backend services, most people, and that's what I do at EA as well, most people are using Java or Kotlin. Some are using Go or Scala. A lot of people are using Node.js, for example. Jank is definitely going to be competitive in that space, but also when it comes to making like a GUI application, if you wanted to make a zoom GUI application, you could definitely do the whole window, all of the features and buttons, everything like that in Jank. And then because of Jank C++ interop for the actual encoding, decoding of video and everything like that, you would call out into a C++, like a native C++ library. So my experience in terms of the performance profile with Jank and my expectations going forward are Jank is going to be able to do everything that I want it to do in terms of application development from like non-real-time, super fast-paced games, but just like a normal game that maybe you run on your mobile phone or something like that, to backend server development, to GUI development. And if I use it for like operating system development, I would be accepting at that point that it's going to be slower, significantly slower, but it's going to be written in Jank. So like it's not like a practical thing in that case.
Okay. Yeah, my question was in that sense that where basically you say you compete with JVM, or you don't have real-time use cases, but what we do in Clink and what we also do in Clunk REPL, we optimize for high performance use cases, and that's why I was trying to see if that's relevant. But also there is this trade-off where you gotta know where are your hot loops, because otherwise you're losing up. You cannot just say you cannot just tell the JIT to optimize at the highest possible level, because if the thing is cold, then you kind of draw on yourself.
Right, exactly. Yeah, and I was watching a talk where you were explaining this recently, and I was thinking about this and how in Clojure CLR, which people are using with Unity 3D, the game engine, in a project called Arcadia, which is the combination of Clojure CLR and Unity 3D. There was some really neat work done by a guy called Nasser, who does a lot of compiler work on like in a CLR flavored way. He built a compiler called Magic, and basically he added some macros to Clojure to say, I want you to optimize these things, and so you could wrap it around some code that is going to be hot, and it's going to, when it just in time compiles that, it's going to optimize it in a much better way. I think one of the benefits of Clojure having the macros that it has is that it's very easy to do these things on a code level, so that you can actually just say, yep, I want to optimize this guy. The rest of it can be O0, but this guy definitely needs to be O2 or something like that.
Okay, thank you. I have two more questions actually, but I want to give people a chance to ask on their own. Are there more questions or comments?
Hi everyone, my name is Stefan. I would have a question.
Hi Stefan.
Sure.
Okay. So one of the points, I guess, is not necessarily the performance of the Jank code itself, but maybe the interaction with C++ code. And so is there a way to load compiled C++ code in the REPL that you have? Like to have external object files loaded and interact with them from Jank? Is that one of the use cases, or is that practically or possible in your case?
Yes. So the bulk of what I'm getting out of this is actually coming from Cling. But I think the way that this would generally look is if you have first off, if you have something that Cling can load, which could be, it could be C++ files, it could be LLVM IR files, then great, you can do that. But also, if you just have some headers that headers in a shared library, then we could also do that. So you can learn about the API. We can load the dynamic library, and then you can start calling into those functions. In terms of like C++ object files, I don't know yet.
All right. So dynamic libraries would be fine, I guess, as well.
Yeah, dynamic libraries, I think, are the easy case. I don't know yet about getting object files in.
Okay, but that answers basically my question. So this is a use case to have like maybe the highly optimized code loaded as a shared library and then interact with it from the REPL in Jank. Okay, thank you.
Yep.
Other questions or comments?
Hi, yeah, I have a question. So what in terms of Clojure coverage, what do you have in terms of, do you cover pretty much everything? And also in terms of data structure, the Clojure data structure are very particular. They are persistent and immutable. Do you port also this data structure to Jank?
Yeah, thanks, Bruno. So Jank's current progress with regard to Clojure parity is for this iteration of Jank is syntactically I support about half of Clojure at this point. I'm missing some pretty basic things as well, because I was basically just trying to prove that this can work in the native world to achieve this interactive programming that I'm used to. So I optimize for like integers and strings, but I think I very recently just added support for floats. For example, I don't think I support bools at this point, even at the lecture level. So there's more that needs to be done to just sort of flesh that out. But the hard work, I think, in terms of like proving this is viable has been done. I think the rest of meeting parity with Clojure is busy work, kind of. In terms of the data structures, fortunately, I don't need to write those because there is a oh, my screen turned off. There's a library called immer that's on C++. That's on GitHub for C++. Some of you may have heard about it. There's actually an equivalent in Rust as well called imrs, I believe. But they're basically Clojure's data structures that have been implemented in C++ and then in Rust as well, that are really highly tuned and thoroughly benchmarked in a way that gives me a lot of confidence and a lot of relief that I don't need to work on that.
Fantastic, great. And I have another question, if I may. So you said that Jank is not garbage collected. So how does the memory management work?
Right now, it's reference counting, and I'm not stuck with that right now. I'm sort of exploring, what can be done. It's tough, coming from C++. I really like RAI and deterministic object lifetimes. But when everything is a persistent immutable value, you care actually a lot less about how long it lives, right? Because we're not working with classes that, for the most part, have constructors and destructors that are doing effects for complex things. We're for the most part just working with data. And that, first off, is tough for people who aren't used. It was very tough for me to figure out how to write Clojure, in that way, rather than writing it, like a C++ programmer would. But I found that it is lovely. And so tying that back to your question, there are some neat things I've read, the ways of handling memory management, like generational memory, that I'm like, wow, this is really cool. I wonder if I could apply this to Jank. And then I look at it, I'm like, actually, no, because like lifetimes are odd when everything can just live because it's persistent and immutable, and you don't really need to worry about who's borrowing it. The idea of like Rust's borrow checker, for example, following lifetimes and mutable borrows doesn't apply, because everything is just immutable, except for like there are like well, everything is immutable or transactional for the most part. Any sort of operations you'd be doing on one of those containers that holds an immutable value is just going to be transactional. There are some small exceptions, which is like we have transients, which are if you just need to like quickly build up a vector of something and it's a hot loop for you, rather than using a reduce or a map or a function to do that for you and have a lot of garbage basically of immutable structures along the way. You can use a transient, which allows you to hit at it in place and then promote it to a persistent data structure. We don't actually use those that often, but they are useful when they're needed. Anyway, long answer for right now. Reference counting, not quite sure going forward.
Okay, thank you very much. Great work.
Thank you, bro. Appreciate it.
We have maybe time for one more question. Okay, I can ask mine. I have two questions, one of which I can turn into a comment. So if you need any link features, please let us know, and I'm happy to help. And the other question is, since I saw you are kind of pulling in data in one of your demos, and playing with data, have you considered developing once you put your Jank REPL? Have you considered having it in the integration with like a system for data analysis like Jupyter or something like that?
Well, I haven't, Vasil, because I'm not familiar with those systems. Coming from the gaming world, is not something that we use. Like I've heard about it, and then I was looking into it with regard to Kling. But I mean, if it's going to be useful, like, and especially if there are people who are interested in Jank in that sort of space, then by all means, I mean, that seems like an exciting world. I don't know about like how the methodologies, and the paradigm of Clojure's pure data transformations fits into that. But if I had to say Clojure is good at one thing, it is transforming data from one shape to another. And what Clojure programmers do, like the mentality that we have is literally with every program we write, it's how do I model whatever my data is? Maybe it's a stream, it's an infinite sequence of user inputs that we model in terms of data. And then in a kind of functional reactive programming kind of way, but not actually FRP, we transform that into our internal model representation. We transform that into whatever we need to put into the DB or whatever, and it's all just data transformation. So I mean, it could be a really great fit.
So for me, if I summarize with one word what Jupyter is, it's a system that promotes interactive programming for data science. And the way that I saw personally how your JSON becomes part of your variables, I think many people would really want that, because that has like a major simplification, right? Basically your configuration becomes part of your language, and it becomes probably easier to process. So that when I saw that immediately struck me, and I just wanted to ask out loud. Okay. Any more questions or comments? I don't think we have time for them, but okay, if not, I would like to thank again Jay. Thanks for your exciting talk, and thanks everybody for joining. Next time we will be meeting on November 3rd, and we will be talking about more low-level stuff in terms of org and JIT-link. Thanks a lot, and talk to you soon. Bye-bye.
Thank you.